Hello Earthians! Welcome to Universal Symphony, the perfect place to explore more, to know more, and to understand more about the universe we're living in. If you want to be apart from this, don't hesitate to subscribe in the channel and like the video. In this episode, we will try to answer about so deep and fundamental question, which is, what is the origin of the universe? How all this greatness started? Unfortunately, we wasn't around when everything started, but scientists in different ages kept trying to solve this mystery in order to find an answer can satisfy the curiosity. So let's take a look about what they found out. From the most popular theories, the Big Bang Theory, proposed by the Belgian Georges Lemaitre in 1927. Depending on it, before 13.8 billion years, the universe was no more than a small dot with super high temperature and huge density, which inflated the cosmos that we know today. In the first seconds after the Great Inflation, space was expanding faster than the speed of light. During this period, it doubled in size at least 90 times, and it was being cooler and cooler, and matter was formed. Then it was filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. And after 3 minutes, protons and neutrons collided to make deuterium. Most of it combined to make helium, and a trace amount of lithium were also generated. About 400 million years after the Big Bang, the universe began to emerge from the cosmic dark ages. Clumps of gas collapsed inward to form the first stars and young galaxies. And when the universe reached half its present size, nuclear reaction in stars had produced most of the heavy elements from which terrestrial planets were made. And that's how our solar system shone up. That's how our planet came finally to existence 5 billion years ago. And that's really an amazing story. The Big Bang Theory represented the adopted theory in the scientific community about the birth of the cosmos. And thanks to modern science and technology, because it allowed us to use telescopes on the ground and in space to detect light from galaxies billions of light years away, showing us what the universe looked like when it was young. And satellites which detect the cosmic background radiation left over from the early stage of expansion. And another evidence that in 1929, Edwin Hubble provided a comprehensive observational foundation for low matter theory, which is relative to the Earth and all other observed bodies. Galaxies are receding in every direction, with a speed proportional to their distance, and that was known as the Hubble law. And that means that space is expanding in an accelerated way, and that implies that the cosmos have evolved from dense concentration of matter. The steady-state theory was first put forward in 1948 by a British scientist, Sir Hermann Bondi, Thomas Gould, and Sir Fred Hoyle. In this model, the universe has no beginning or an end in time, and it's always expanding, but maintaining a constant average density due to a continuous creation of matter. This model is rejected by the vast majority of cosmologists, astrophysicists, and astronomers, because last observations began to support the idea that the universe was in fact changing, and its definitive refutation came with the discovery of the cosmic microwave background in 1964. And before moving on, let's take a quick view about what's the meaning of the cosmic microwave background. Well, it's an electromagnetic radiation which is a remnant from an early stage of the universe, and it's filling all space. It represents the oldest electromagnetic radiation in the whole cosmos. And finally, we have the plasma universe. This model starts by noting that 99% of the observable universe is made of plasma, which is an ionized gas that conducts electricity. This theory states that the Big Bang never happened, and the universe has existed forever, under the influence of electromagnetic force.